Hi, I'm a food rheologist and I am currently on sabbatical. While I'm on sabbatical, I'm making a video series about rheology that I find in everyday life. And this video is about the rheology of chocolate milk. Specifically, why does the commercial chocolate milk stay so smooth and homogeneous versus homemade chocolate milk, which separates very quickly if you store it and don't drink it right away? So here's what I'm talking about. This is what commercial chocolate milk usually looks like. It's this lovely, smooth, opaque brown. It will stay like this, looks exactly like this on the store shelf, and it doesn't matter if you bring it home and then you decide, well, I'll wait a few days before I drink it, it'll be fine. It won't separate. Versus if you make chocolate milk at home, it doesn't even look like that at first. It's not quite as opaque, and then within an hour it separates, and here's all your cocoa down here, and then this is mostly the milk you use to make your chocolate milk. Why does it do that? This is the answer. We put something in commercial chocolate milk so that it won't separate, and that something is called Carrageenan. No, we do not put seaweed directly in your milk. Don't worry, you're not going to open a milk container and find a piece of red seaweed floating around in there. What we do is we take this seaweed, this Carrageenan, and we extract out the Carrageenan polysaccharide. A polysaccharide is basically just a little chain of glucoses and other small sugar-type molecules that are just making a very, very long chain. Starch is an example of a polysaccharide, so it's a lot of glucoses hooked together. Carrageenan isn't just glucose hooked together, but it's a lot of small molecules like glucose hooked together. It's not digestible, but it won't hurt you. All it does is make a little network in your chocolate milk, and it traps those heavy cocoa particles right here. Those cocoa particles are denser than your milk, so eventually they'll settle to the bottom, and that's why your chocolate milk separates. But Carrageenan will form a net, and it will hold that cocoa in place. It's a very loose net, so you're not really going to notice anything clumpy or gel-like or gummy when you drink your commercial chocolate milk. It may feel a little bit thicker than homemade chocolate milk, and that's because you're sensing the increased viscosity that this network is providing. The network also provides what's called the yield stress, and that just means that you have to put a little bit of force to get the material to flow. In case of chocolate milk, tilting the bottle is enough to overcome the yield stress and let the chocolate milk flow right out of that bottle into your glass. But you can kind of see that there is a yield stress in commercial chocolate milk if you take a very close look at the top of that chocolate milk in your glass. This is what it looks like. It's a bit exaggerated so you can see it, but when you first pour that chocolate milk into your glass, you'll see this convex shape here. Eventually it'll settle down and reach that black line. That convex shape is because of the yield stress, and the relaxation you see down at the black line is it flows under its own weight. So its own weight is overcoming that yield stress. But that's the way you can kind of see the yield stress. You can also see the yield stress in action because this lovely smooth brown color here stays lovely and opaque. It doesn't separate. And that's why commercial chocolate milk stays mixed and your homemade chocolate milk doesn't. If you want your homemade chocolate milk to stay mixed, then figure out, okay, how can I get something like Carrageenan to keep my chocolate milk mixed, or just drink it really quickly before it has time to separate.